Good afternoon, ladies and gentlemen, and a very warm welcome to Reimagining Tech in 2022, presented by Google Cloud and ATCIO. In the path towards making a mark in our endeavor, we have successfully conducted 8 workshops till now, and this is the 9th one. We appreciate you all being a part of this innovative series of workshops around cutting-edge cloud technologies by seasoned technology leaders and Google Cloud experts. The sessions have been conceptualized keeping in mind IT leaders who are looking to gain actionable insights to support their organization's digital growth strategies. Well, today's workshop is focused on reimagining DevSecOps strategies for the cloud. The business imperatives around speed, agility, and scalability are driving organizations to develop apps on cloud. However, security continues to be a key concerning factor. Embracing agile development methodology enabled with DevOps as they migrate applications to the cloud, it's critical that businesses embed security into their development operating model. The major key points of discussion today will focus on how to secure cloud-based applications more effectively with DevSecOps, strategic and cultural implications of adopting the DevSecOps principles in the cloud, better understanding of DevSecOps tools and processes in the cloud environment, automating security and configuration of assets in the cloud. And now, without wasting much time, let's start with our workshop on Reimagining Tech in 2022, Reimagining DevSecOps Strategy for the Cloud. I would welcome our first keynote speaker, Mr. Aseem Rastogi, Head of CyberSecurity and Compliance, Meesho. I request you to kindly deliver the address. We also have a Q&A session at the end of the workshop, so we request our viewers to keep posting your questions and our speakers will be happy to take them up.
Hello, everyone. Hi, my name is Aseem. I'm Head of Cybersecurity and Compliance at Meesho. I have about 24 years of experience in IT industry, and most of it is in cybersecurity. Before Meesho, I was heading cybersecurity and compliance at Razorpay. And I've been an entrepreneur, worked across multiple countries and so on and so forth. And without taking too much time on that, I'd like to jump right into this topic, DevSecOps. So one of the things I guess we need to cover and understand is what is the business problem DevSecOps is trying to solve, right? And how this has come into being. So this a brief historical perspective around it. If we see our development in earlier era, the development team used to do the development, and there will be a few system admins who will be taking those code and executables, etc., and then pushing it out to production. So that's how this thing worked. Now, there were several challenges into that because there are several handovers which is required from one team to another, and a lot of handovers and etc. means scope for mistakes. And as soon as that is there, your speed and velocity of the deployment and the pushing out new features drops down significantly. So we might recall it used to take about release used to happen like every 2 weeks or a month at some places, and the SDLC was really slow. And now what's happening over the years is that the velocity has changed a lot. It has increased many fold. Customers are omni-channel. They are coming from mobile, they're coming from web, they're coming from voice, live stream, videos, right? So it's all over the place. And customers are coming from everywhere. And that requires a lot of new features to be pushed out, old bugs needs to be fixed, and the velocity has to increase many fold. So once a month release or twice a month release doesn't work. So that was kind of business driver, which was pushing things out to create a seamless experience within the organization to go for more integrated approach of pushing software out. So that's how incrementally DevSecOps was kind of coming into being, where developers will be finishing their job or whatever, right? And then there will be an automation in place which will do the merging of all the codes and packaging and things like that, and then push it out to production and deploy it. So more automation required a lot of new type of skill sets from a talent side, new tools out there to account for multiple languages which were coming into being, like Node.js and maybe React or Angular, those kind of new age software development languages, etc. So that's how this DevSecOps was born. And I mean, DevOps was born kind of, right, into deployment. Now, security has not come into place yet, right? Now, if you are doing this kind of packaging and deployment, security can never be behind, right? It has to be, the entire process has to be secure as well as there are multiple things which you need to do in terms of security, like a static code reviews, right? Or static SAST, right? And so those things, DAST, automated testing. So these kind of things which were being done in a manner where the release will be held up. So your developers will be waiting while the security team is doing the testing, etc. And then the code gets pushed out later stages. So that was holding things up a bit. So once you look at on the automation side, there are multiple things which can be done. One of them is code reviews now and secure analysis of the static code. Now this there are a lot of tools out there which you can integrate with your CI/CD pipeline, and that way as soon as the developer does a check-in and does a merge, you can detect that, and the cost of delivery and all that goes down, because now what you are doing is you are finding out the security issues much earlier in the cycle, and because of that it goes down. So that's the prime benefit, and security gets integrated in each of the stage. Now if you look at the entire process of your development cycle, right? So there is a plan phase, code phase, build and test phase, right? That's on the dev side. And on the ops side, you have release, deployment, operate, and then monitor. So security gets integrated into every stage of this process. Now we'll look into how that happens, right? So from the coding side, once you are doing the coding, you have several tools set out there, static rules out there, which you can do language-specific rules for secure coding. So those are the things which you can integrate with your development environment, where the check happens on the spot, and the insecure code doesn't even get pushed out, right? And then afterwards, during the release cycle, you can run several tools. Like for example, if you are using Terraform for your infrastructure on cloud build, right? Then what you can do is you can use certain tools out there to scan your Terraform pipeline, right? And then find those challenges early on, right? So that's another benefit of that. Now, if you are using, say, any kind of testing for regression testing or suite, etc., so those things also can be integrated. So all these things put together enhance the security of the deliverable early on, and then at the same time, it increases the velocity. Now, if this is such a good thing, then what are the certain challenges here? So this as we can see that it requires a lot of collaboration between various teams, because there's development team out there, there's security team, and then you have DevOps team who is owner of the cloud infrastructure and so on, right? So there are multiple teams who have to work together collaboratively. Let's understand it with one example. The way we try to address this problem is, so we have a security team which puts together any, say, let's say, secure coding guidelines, right? How those secure, how the code should be written, and how the security should be taken care in the code. Now, there are certain aspects of that code which can be detected automatically from a security standpoint. Now that gets encoded into a tool like SemGraph or any other tool for that matter, right? Works well. So once that happens, then developer can run that on their own laptops, etc., on their IDE environment, etc., and they can detect those areas of fixes in terms of security. Now, second stage comes when there is a master merge on that same code. Now, that's when on the entire code base, security team runs a security check and then finds all the issues which were probably missed or may have been overlooked by the development team early on due to various factors. Now that can be reported on. So with that reporting, you get a holistic view of all the issues across the your landscape. So that gives a very good visibility in terms of management and provide the assurance of certain level of security. And that's how the organization can scale up the cybersecurity maturity curve. So that's how this DevSecOps helps the organization. And there are cultural aspects also, right? Because there are certain issues which can be done, which needs to be done collaboratively. For example, if we are building, say, a container image. Now, container image is a joint enterprise of multiple people. There's an operating system on that with the base image, and then you have infrastructure setup, etc., whatever is required for application to run, and then you have application level packages. Now, all that is scanned by security team. There are certain challenges. Now, when the security team detects an issue at an operating system, all the team have to work together to fix that. It's because if just a DevOps team goes and patches the operating system, application may stop working, or application team may not know what patches needs to be done, right? Even if security team tells this patches, it's not very easy to be able to go and test everything what could be wrong, right? If it's a kernel level fix which has come in, it's very difficult. So those are the challenges which are still open, and still those issues needs to be resolved in a sense. So now, if we look into these aspect, right, from a management point of view, let's look at some of the aspect how we need to kind of manage this process, right? What are certain KPIs which needs to be managed and done, right? So it will be a percentage of issues found per kilo lines of code, right, per developer per month. So that could be one good metric to go about, and that will provide how effective our DevSecOps program has been, right? Whether it is finding issues, whether it is finding issues of high priority or not, whether the code is what is being pushed out is of high quality or not, right? Then second issue could be, second KPI could be what is the fixed SLA. So if we at an org level, if we decide certain SLAs of P0s or P1s, depending on the severity of the issues, then what is the SLA looks like? It gets fixed in 2 days, 4 days, and 8 days, depending on organizations, it can be set up. So these are certain at a management level things can be done. And if we look at from a future direction, DevSecOps is certainly the future because it has increased velocity several folds. And then we are doing now delivery several times a day. It's not anymore a scheduled activity where all the teams have to come together to put up a release. It's all automated, and those automation is taking good care of all those velocity of the features. So our customers get features quite fast, and they're not independent. So even though we are having multiple teams which are running independently, we don't step on each other because of good processes in terms of our DevSecOps. So those are the some of the benefits and how we see DevSecOps going forward in terms of future direction. Thank you.
Thank you, Aseem, for kickstarting this workshop and setting the context aptly. As security in the cloud takes center stage, organizations are adopting a shift left approach while developing apps on the cloud with DevSecOps, re-architecting their cloud security model around the security by design approach. DevSecOps enables businesses to create more secure and agile applications in the cloud, thereby enhancing the security of their cloud environments. The workshop will look at effectively adopting DevSecOps principles in the cloud. This workshop will enable technology leaders to unleash the full potential of DevSecOps strategy in the present scenario. Now, ladies and gentlemen, to delve deeper in these areas, I would like to invite our second speaker, Akshay Kapoor, Technology Practice Lead India Application Ecosystem at Google Cloud. I would like to remind you all that you can post your questions in the questions section, as we will have a Q&A session at the end of the workshop.
Thanks, Aseem, for your insights on such an important topic. Hello, everyone. My name is Akshay Kapoor, and I am a customer engineer at Google Cloud. Now, with every organization having adopted DevOps to some extent and security being the top concern for all CIOs, CTOs, today I'll be talking about why organizations should look at DevSecOps in cloud, and more importantly, how to go about making it part of their overall strategy. So let's dive in. So what is DevSecOps? By definition, it is a practice in application security that involves introducing security earlier in the software development lifecycle. So what that means is, how can you have security baked into your development, build, and deployment process that is not an afterthought when deploying applications in production? As we like to call it, the shift left principle, meaning shifting security earlier in the software development lifecycle. Now, to share some perspective as to why this is becoming even more important is because newer attacks are on the rise. And one thing common in each of these attacks is that they don't have anything in common. Let me share a few examples of them. This attack involved the hackers compromising the infrastructure of SolarWinds, a company that produces a network and application monitoring platform. SolarWinds had their KMS compromised, which resulted in the build systems getting compromised. The incident highlights the severe impact software supply chain attacks can have, and the unfortunate fact that most organizations are unprepared to prevent and detect threats. Let's take another attack. Let's take a look at another attack. I'm sure most of us have heard of the popular dependencies like Log4j, OpenSSL, and Spring have had exploitable vulnerabilities of late. Now, this introduced another attack surface, which caused vulnerabilities in the dependencies and not getting noticed until the application was deployed and exploited. So far, we've seen build systems compromised, and this one showing dependencies which can be compromised too. Another attack, the code curve attack. Now, this attack was done by a very sophisticated hacker who exploited a mistake in how code curve built Docker images. Now, they used it to modify a script which allowed them to send environment variables from the CI of code curve customers to a remote server. As depicted in this diagram, there are many attack vectors in this case, and it only takes one unsecured link to breach the entire software supply chain. Now, if you bring all of it together, there is a possible entry point at each stage of the software development lifecycle. Right from injecting bad code or having a compromised source control, which would lead to your packages being built from modified sources, and which would eventually have compromised the build systems, leading to a compromised package being built. And when you deploy these compromised packages, it's only when a breach happens or a vulnerability is exposed we come to know of it post deployments. Solving for these attacks requires one to comprehensively look at software supply chain. It's not SecOps which is responsible for maintaining the security posture. Hence, it is even more important to have all the teams involved to work together to make sure that everything is security first. Now, analysts have listed out many more attack vectors and also view this as a very important aspect of software development lifecycle going into the future. Now, Gartner research suggests that these attack vectors to be the most common and something that engineering leaders should look to solve for. And you would see attacks surface in various phases right from develop to the deploy phase. Interestingly, if you look at the predictions of technology going into 2025, it's astonishing to see that 45% of organizations worldwide will have experienced an attack on their supply chain by 2025. And because of how applications are going to be architected, written, and deployed, software supply chain security risks are going to be imminent. Achieving all this while making sure that developer productivity is enhanced, leading to better engineering maturity, will be key to adopting new frameworks and solutions for enterprises. And if I have to summarize all the contributing factors of these attacks, most importantly, nearly everyone relies on open source software, which at times introduces unknown contributions and expands the attack surface of the supply chain. Secondly, everyone wants to fasten the development cycle in order to release new features faster, which most of the time leads to security really being an afterthought and not ingrained into the development workflow, which would eventually lead to multiple attack vectors and makes it difficult to understand at various exposure levels. And most importantly, there are no emerging standards to keep up with the newer ways of development. At Google Cloud, we understand this and we've solved it in two ways. First, we brought in thought leadership with our experience of building for security first internally for decades and collaborated with other organizations to build a framework on improving the security ecosystem for everyone. This is called SALSA, supply chain levels for software artifacts. And secondly, we introduced products and features as part of software delivery shield. Let's take a look at both of these in a little more detail. So what is SALSA? It's a security framework, a checklist of standards and controls to prevent tampering, improving integrity, and secure packages and infrastructure in your projects, businesses, or enterprises. It's how you get from safe enough to being as resilient as possible at any link in the chain. This framework helps automate analyzing artifacts, guarantees original source code, protect against interferences in build and distribution processes, isolate any hidden vulnerabilities, and knowing which components are affected by vulnerabilities. SALSA levels are like a common language to talk about how secure software, supply chain, and their components really are. From source to system, the levels blend together industry recognized best practices to create 4 compliance levels of increasing assurance. The idea being you comply to these levels basis the level of security you can accomplish in your development life cycles. Knowing about these levels is just one part of the challenge. Having the right tools to help you comply with these levels will be key to adopting these frameworks. And Google Cloud has introduced Software Delivery Shield. So what is it? Well, it offers a whole bunch of features with many products supporting the same. From a development perspective, imagine you can now know about vulnerabilities when the developer is coding right in the IDE. And enterprises can now also provide a secure browser-based IDE with all security features baked in. From package or other supply perspective, organizations can now leverage trusted open source packages and have vulnerability scanning right at the time of building the application. From CI/CD perspective, having build provenance in place to be able to define software bill of materials. And most importantly, during runtime, you can now be sure that only verified packages are running, which can be validated by a policy. Now, to give you a sense of where all can Google Cloud help you after having denied on so many vector attacks, let us just revisit this slide again, showing different phases of the development process. At Google Cloud, the attack vectors labeled from A to H can be solved with SALSA standards built into our products. And you get more with Software Delivery Shield, which helps in runtime and continuous assessment of the deployed workloads with assurance. So, an end-to-end DevSecOps pipeline would look like this, making sure that you achieve the right level of SALSA while deploying your application securely and improving the developer productivity. Now, let's look at all of these products in a little more detail. Starting with Develop. Cloud Workstations provides a fully managed development environment in the cloud, supporting popular IDEs like VS Code and IntelliJ. On top of this, Cloud Workstation comes with a number of built-in security features to help IT administrators and operators secure your development environment. Administrators are able to control private ingress and egress while using service controls to prevent data exfiltration. Now, this can help ensure your source code doesn't leave your organization's perimeter at all at any given time. Cloud Workstation also provides forced image updates and granular IAM access policies to make sure that developers are always using the latest secured development environment. Now, continuing with the development phase, Cloud Code Source Protect brings dependency vulnerability and license awareness directly into the IDE without blocking any productivity whatsoever. This all works seamlessly with Cloud Workstations. Now, with Cloud Workstations and Cloud Code Source Protect, your IT administrators and developers can save hours in securely managing a development environment and creating secure applications for the future. We are also providing new artifact management capabilities to help secure your dependencies. Artifact Registry now supports virtual and remote repositories, further strengthening the dependency governance and simplifying the access points. On-push vulnerability scanning in Artifact Registry with container analysis has been expanded to include Go and Maven containers. We now also support scanning of non-containerized Maven packages. And now, software bill of material dependency lists can also be generated for containerized applications to gain a better understanding of all your third-party dependencies that are part of your application. In addition to this, assured open source software provides a trusted portfolio of over 250 Java and Python open source packages. These packages are built in your secured pipelines with software delivery shield services and are regularly scanned, analyzed, and fuzz tested for vulnerabilities if it may arise. Now, when it comes to building applications securely, Cloud Build has you covered for providing out-of-the-box Salsa Level 3 builds. Now, in addition to already providing ephemeral and isolated build environments, Cloud Build now provides you with automated and non-falsified build provenance. This is available for containerized applications and Maven and Python packages, providing you with the auditability into how your applications were built with zero configuration security guardrails in place. We are also introducing a new security insights panel inside Cloud Build itself, so you can immediately understand the security posture of your build artifacts. The security insights panel displays the Salsa build levels, vulnerability information, dependencies, and build provenance for build artifacts. And once your applications are deployed to GKE or Cloud Run, additional security insights will be present right at the runtime. GKE, which is nothing but Google Kubernetes Engine, provides continuous runtime vulnerability scanning of your workloads and also analyzes your Kubernetes configurations against the pod specification standards and highlighting any deviances. And Cloud Run with built-in security panel has been enriched with Salsa build levels, vulnerability information, and build provenance for your containers. Finally, binary authorizations trust-based policies can be used to turn all these security insights into actionable policies. With trust-based policies, you can create attestations for specific processes that need to be followed or for tools that need to be used before any application can be permitted to run. These policies can be applied and enforced on runtimes such as GKE and Cloud Run. Now let me show you how everything comes together in a demo. Let's start with developer environments. Cloud Workstations provides customized developer environments that allows developers to be up and running quickly with just the pieces that they need for a particular project. We can create custom profiles that can be set up within private networks. We can minimize data exfiltration risks and also customize the environment so I can select the CPU, RAM, and the GPU profiles that I need. I can also do things like select the ID that's going to run. I can also create a completely customized container image that would allow me to have full control over all tools running within that. We're going to be working on a Java environment. So I'm just going to launch our Java dev profiles, which has all the tools that I need, including these Eclipse JDK. I also have Maven installed. So we're going to be working with a Maven project today. I also have Artifact Registry's new remote repository configured. This allows for proximate caching of my dependencies for speeding things up. I've also got that configured, of course, within my pom.xml to read from that registry so I can get started with my Maven work. Let's shift gears and talk about dependencies and talk about how securing these dependencies against vulnerabilities. Cloud Code has a new capability called Source Protect. Now, Source Protect will provide linting style, as you can see this kind of red underlining, linting style of notifications of vulnerabilities that are lurking within dependencies that you define. In this case, I'm looking at the pom.xml file and you can see all the vulnerabilities that are lurking with those dependencies. And now, if I update one of the versions here, you can see that the count drops from 15 to 12 problems. And I can work through the pom.xml and address all these problems right from development itself. Now, I'm actually going to just go ahead and commit, and we're going to kick off a build within Cloud Build. Cloud Build can be configured to use all those tools we talked about. In this case, I've got my Maven builder. I've also got Docker. Docker is going to help me containerize my application and ultimately push to artifact registry the compiled image. Now I've configured a vulnerability scanning policy. On push, I'm going to be scanning for vulnerabilities. What this policy does is it will fail the build if that policy has not been met. Basically, the thresholds are exceeded. In this case, it has. Now we know that there are 12 problems still lurking there. And you can see that in this case, the Cloud Build caught those problems and we were able to stop the build without proceeding to the deployment. We can take a look at the actual image that was produced and housed in the artifact registry. Artifact registry provides vulnerability scanning basically. On push, it scans, and you can see that apart from the 8 mediums, I have quite a few highs and critical warnings lurking here, both Maven and OS vulnerabilities. So my vulnerability policy stops CI/CD from deploying this image. But what if I try to deploy the image using kubectl directly? So short-circuiting the CI/CD process. Now I'm going to do that and try, and we can actually see that it fails. The reason the deployment fails is because I have an admission control policy set up that blocks any image that has not accumulated proper trust. And this is done by a system called binary authorization. Binary authorization can be configured to set out a policy where you can specify all the trust factors that are required. In this case, I only have 2. I have that it be built by Cloud Build is 1, and it be vulnerability scanned as a second. So as a result, I'm just going to go through and fix all of these problems within this application. I'm going to use Cloud Code here to help me do that. As you can see, Cloud Code will help me not only find the direct dependencies, but also like these ones, which is a transitive dependency. And that would be very challenging to find otherwise. So let's fast forward a bit. We've fixed all of the problems. And now we can kick off another build by triggering via push. And we'll see that once it finishes, it actually passed and we were able to get through that vulnerability policy step on towards a CD via cloud deploy. We can also take a look at a new capability called Security Insights within Cloud Build. This provides information such as the SALSA level that we attain, the build integrity of the particular item. So we can see that there are no vulnerabilities lurking around here. We can inspect all of these dependencies that are in here in any particular image. We can also take a look at the provenance of this image. Think of provenance as the recipe. So this is all of the inputs, including all of the build steps, including the builders that we used, like Maven and Docker in this case. And we can see that we went through the vulnerability policy step. Now, my application has been deployed and it is running in GKE. Now, let's take a look at the security posture more closely, looking at the new security management capability within GKE. Now, this provides an analysis of all my running workloads on the various clusters I have. In this case, I have 3 clusters, 13 running workloads, and then it looks at things like configuration concerns. Now, these are pod spec considerations, also, of course, vulnerabilities. So this is a daily scan of OS vulnerabilities that comes with GKE. So I have a drill down interface where I can slice by various perspectives like concern or namespace or even workload. I can also do things like filter by severity. So in this case, I'm going to prioritize my time and focus on the most important things. In this case, I have a high CVSS score vulnerability, as you can see, with a fix at hand so that I can go ahead and remediate. I also know where to remediate. And this is one of the great things about security posture management in GKE. It ties together not just the problems, but it pulls them into the context of where it is and where in your workloads these things reside. Let's take a look at our application, the Maven application we just deployed. And we can go ahead and filter for the cluster, and I can see my demo application. And I can see that there are actually two medium level suggestions. One is that we are running as root, and the other problem is that my pod security specs allows for privilege escalation. Armed with where it is and how to fix it, I can just update the YAML file and make the changes to this particular workload. This is how we achieve end-to-end DevSecOps with Google Cloud, achieving the highest level of security standards. That's it from my side. Thank you so much for your time and patiently listening to us.
Thank you so much, Akshay, for the in-depth and comprehensive presentation. Ladies and gentlemen, as promised, it is now time for the Q&A session. We have received a number of queries throughout the workshop, but we will be putting across very relevant and pertinent questions to our guests on the workshop topic and try finding the answers to them. Well, let me once again introduce our guests for this show. Aseem Rastogi, Head of Cybersecurity and Compliance Meesho, and Akshay Kapoor, Technology Practice Lead India, Application Ecosystem at Google Cloud. Now, heading straight to our Q&A sessions, we have received a number of queries throughout the workshop. Well, starting with Aseem first. Aseem, I would like to understand that what is the Meesho security stack at the present?
Right. So thanks, Smriti, for the question. So at Meesho, our security stack is quite diverse depending on the security needs, but broadly it is divided into two different segments. One is in the pre-production and second is post-production, right? So in pre-production side, we're talking about DevSecOps, CI/CD pipeline type of tool chain, detecting secrets, detecting any kind of code-related vulnerabilities, package dependencies, those vulnerabilities. So those are some of the items which we look for before we get into production mode. Now, right. In production also, something might slip up or there might be tech debt, etc. So we have pretty robust security monitoring aspects into the production as well. So which will detect, say, cloud-related misconfigurations or any other type of attack patterns, etc., which we are seeing in the market and in our larger ecosystem. So those are the broadly two areas in terms of tech stacks. Yeah.
Right. And Akshay, what are the best practices to secure cloud-based applications with DevSecOps?
So thank you so much for that question, Smithy. And if you really talk about best practices, honestly, there will be too many to list on this call, but let me just give out a few of them so that folks on the call probably get a sense of what are the things to look out for and probably be prepared so that when they start implementing security or other DevSecOps, they're much aware about what are the things to look out for. And in my honest opinion, it really gets down to the basics. You need to make sure, firstly, that your foundations are set right. And what I really mean by that is, think about it, what can you do proactively and what happens reactively, right? So when you think about proactively, things like, do I really have all the monitoring required in a single pane of glass? Do I have things to make sure that I am being alerted when things happen on my stack, right? Likewise, do I have the capability, like Aseem mentioned, to probably detect things while I'm testing or before even I'm going to production, right? These are things that you probably want to make sure that you have either the tools or the solutions in place to probably help you understand these problems. Now, when you talk about reactively, think about if at all there is an issue that you see, how quickly can you react to that problem, right? And when you reacting quickly is one aspect of it, how quickly does your system tell you that you probably need to react to the problem that we're seeing in a system? Now, once you know that the problem is there a way that you can sandbox that particular environment to make sure to fix that problem and it's not scattered throughout your infrastructure, right? So the ability to be able to sandbox a particular environment and make sure you fix it, also making sure that do you have the right tools and processes in place to make sure there's a lot of learning that happens when things like this happen, and it's not repeated ever again in the future, right? So broadly, when you look at these two sort of buckets, it gets down to a point where you need to look at some sort of a framework to probably think through and have your check marks basis on the kind of security posture and what do you call DevOps culture that you have in your organization. And there are a lot of frameworks that are out there, and you would have seen that during call I spoke about Salsa framework specifically, that really talks about a bunch of these things. So that should give you a pretty deep insight into how you should look at implementing best practices from any applications that is deployed in cloud.
Akshay, that was very well answered. And Aseem, how do we understand that how Meesho is adopting a shift left approach when developing apps on the cloud with DevSecOps? And how are they re architecting their cloud security model around the security by design approach?
Right. So yeah, that's a very valid question, and that's as Akshay mentioned, right? This framework is Salsa, right? That those are some of the things which are very handy in shift left conditions. So first, I'll just briefly explain like what is shift left, right? For us, right? We are when we detect issues in say at the end of say pen testing, right? It's too late because by that time design has happened, a lot of code has been written, a lot of things have happened. So the cost of fixing those issues is very high, and the disruption is too high. So we look at it holistically, and I mean, before the code is written, we get into security gets involved.
Right.
We review product specs. So that way, if there are any high hitting design challenges or requirement challenges, those things get caught at a PRD stage itself. That saves enormous cost. Because once the wrong feature gets implemented, you can't do anything. You have to go back to the drawing board and fix it anyway. So we do that before the it gets even to the tech team, right? And then at the tech spec level, that again it gets reviewed at the solutioning point of view, right? So you get two set of reviews right there to get the right security built into that. Now then comes the tool part, right? When the code gets written, at that time we use certain frameworks and tools, tool chain, etc. Right at the developers desktops, etc., right? IDEs to detect issues before they even get to Git, right? And if they get into it, then we have second layer of detection at CI/CD pipeline level, where we can detect certain aspects like maybe any slipping of tokens, etc., or any secrets getting into GitHub, right? Or any vulnerabilities in the libraries, third-party libraries. A lot of third-party libraries we use these days because of a lot of open source, which is very, very good. So instead of rewriting the whole thing, it's better to use that. So those are the some certain aspects which we utilize, and there are certain KPIs which we would like to track. So that way we can find what is the effectiveness of this, right? The security issues should come down when we detect at a pen testing stage. So that's how we look at it from a holistic point of view, from a shift left perspective.
Aseem, that was very well explained and very nicely. Like we got an in-depth look into what we are trying to make our audience also understand. Akshay, with that, I come to you that we have been speaking about Salsa framework. Can you tell us a little more about this framework?
Yeah, absolutely. So if you look at frameworks in general, it's ideally either built by a single organization or other many organizations coming in together and sharing what they've learned over the years of building such such a tool, leveraging tools and processes to make sure that it's really helpful for organizations. Now Google has been implementing and using a lot of these processes in place internally for years, um, and the idea really was Google, along with Citi and many other companies, came together and built a framework around Salsa, right? Which is where it talks about supply chain levels for software artifacts. What that essentially means is organizations contributing together and building a framework so that everybody can follow and make sure that their software supply chain is essentially even more secure than probably one can imagine. Now how do you do that is in many different ways. Google has been doing it in many different ways internally. Likewise, City and many other companies have been doing it in a specific way. And the idea really is to have sort of a recipe in place so that people know what to look out for, right? For example, there are 4 levels in Salsa. Level 1 is it's something which is very easy to adopt. It's as good as taking baby steps, right? So when you adopt level 1, you get some sort of comfort in making sure that your application is secure. As and when you get more comfortable with the approach and implementing more stuff, you can get to things like level 2, level 3, and level 4, right? So it's really giving you a blueprint or a recipe to follow, rather than building your own do it yourself kind of an approach to building a sort of framework which essentially works for one. Now this is being built by organizations who have had tons and tons of experience in this space at planet scale, right? So what organizations like Google and City and others have learned from their own processes is something which is being shared with the community out there so that everybody can adopt. It's very similar to we keep talking about DevOps as such, right? But if you look at DevOps rather, how do you implement DevOps? The answer to that is really SRE, right? Which really gives you a prescriptive approach of the things to follow so that you make sure what are the outcomes that you can achieve. So think of it as it's more of a recipe for organizations who really want to start leveraging DevSecOps. What is really the best way to get started? Salsa framework is really a good way, and I honestly recommend people to go to slsa.dev, which is salsa.dev, and read more about it.
And I must appreciate, Akshay, that was explained in a very interesting manner. I'm sure that people watching our conversation right now will definitely have a better understanding once they have heard you explaining this. Coming to you, Aseem, how Meesho is planning to secure cloud-based applications with DevSecOps?
Yeah, so when it comes to cloud, right, it's very different from traditional model where there are multiple services, there are multiple endpoints, and multiple ways to get into the application for the threat actor. So visibility is the key, right? Once it's in production, you have multiple services. If we take an example of, say, AWS, right? There is an S3, there is RDS, there are images, AMIs, 200 services out there, right? Lambda is there. So there are multiple ways to get compromised. So the visibility is really, really the key, right? Do we have the right visibility to know exactly what all our assets are and what is our exposure surface area, right? As Akshay was mentioning earlier, right? We try to limit the blast radius, right? There should not be too many entry points. It should be rather a very limited set of entry points, and the security team should really need to have a control over those entry points and have that visibility that when this gets modified, right? So those are the visibility is where I think it really helps to secure in cloud.
Absolutely. Akshay, there is one more question for you. What are the key strategic and cultural implications of adopting the DevSecOps principle in the cloud?
I think honestly there'll be many, but let me talk about from a cultural perspective first. So if you look at, I mean, we've been talking about DevOps for many years now, and we keep talking about DevOps as more of a culture. But the important thing to really note is there is no tool that can help you solve DevOps or implement DevOps, right? Tools will never replace people. So it's more of culture. And if you really want to build a high performing team, and I think this is where these are the kind of implications that will happen in your organizations. You will make sure that you will have a very high performing team, making sure that you have the right processes in place. People are wanting to learn more within the organization, leverage the latest tools and technologies to make sure that you are right at the cusp of technology when anything new is implemented, and you can rather onboard any new technology quickly so that you don't have the technical debt that Aseem was talking about a little earlier, right? From a strategic perspective, I think Aseem made a very, very valid point, and I completely echo that sentiment. If you can solve for any issue right during a PRD stage, or even during the design stage, or let's say testing, because every stage increases the cost of solving that particular issue exponentially. And I was reading an article the other day. It was talking about if you have to solve for an issue in production, it's 50 times more expensive than solving it during the development phase, right? So look at it from an organization perspective, right? The development cycle that it takes, the amount of time required, the cost implications, and everything around it, right? That in turn allows organizations to go to market much faster. It gives you the bandwidth and make sure that you can release features faster. You can go to market newer businesses, newer initiatives. You can probably leverage that time and go to market much faster, right? So if you look at it, it's really all in all a win-win for organizations. But let me also put it out there that this is really a journey, right? That it's not that if you think of implementing DevSecOps in stage one and you'll be successful. It's a journey. And I think once you onboard onto that journey, you want to make sure that you keep accomplishing and achieving more and more milestones rather than thinking of accomplishing it all at once.
Absolutely. Aseem, a follow-up question to what I asked Akshay. What are the DevSecOps tools and processes Meesho uses for securing in the cloud environment?
Right. So from a tool chain point of view, we use certain tools like, say, for secret detection. And so that helps us detect any kind of secrets which might be present or inadvertently put into the code, right? So that's one of the aspects, right? The other tools we really use well is SEMGraph, which is really helpful to detect security related vulnerabilities, and that gives us a clear edge because that's very customizable tool, right? And that way, from a customization point of view, we can tailor it to our very specific requirements, and that has helped us solve a lot of problems early on. And as Akshay was mentioning earlier about the cost, right? So everybody is very sensitive about cost of fixes, because security is largely seen as a cost center, right? So we must save cost while we can. So this DevSecOps strategy is really helpful in that sense, that we can bring all the issues earlier in the life cycle and solve it right there when it arises. So that
Right.
just helps everybody, and everybody appreciates what security is bringing to the table in that case.
Aseem, there is one more audience question for you, that how can an organization and a cloud vendor manage the gaps in process, visibility, and security between the development and operations teams?
Right. So yeah, I mean, as I mentioned earlier, right, the visibility is the key. If say there is third parties involved in management of the infrastructure, etc., then it becomes rather more pertinent to have a lot more visibility about the access which third parties having. What is the security posture of the third party? Because that becomes your own. If they get compromised, the production gets compromised. It doesn't matter how secure you are as a company, but if a third party who is supporting you, helping you in cloud, gets compromised, so all bets are off, right? So those are the challenges where vendor management is really the key in that particular scenario. Yeah.
Right. Right. Akshay, how do you recommend organizations who want to get started with the DevSecOps journey in their organization?
I think that's a very important and a very valid question for this session. Uh, I think, like I mentioned earlier, right, getting your foundations right. I really talk about getting your foundations right because that is really core to DevSecOps in general, right? And if you look at, and I quote what Aseem mentioned, right, it's about getting visibility in the first place. So
Right.
when I say foundations right, it's meaning you need to have the visibility in place to make sure that you're monitoring everything. At least you're aware about things that are happening on your stack, and you can go about answering the questions to yourself and understanding, do I have all of the monitoring required in place? uh, will I be able to address new changes without affecting the current environment in any which ways, right? And most importantly, and I think it is important for you to follow some sort of framework. I talk about Salsa, but there might be other frameworks as well that you would want to probably look at and leverage. whatever that framework is, leverage that framework and make sure that the tools that you use, any tool that you want to use, supports and gives you the flexibility to incorporate that framework in the tools. There is no point in using a tool that gives you everything, but you don't know what to do with the matrices that are there, and what does it really reflect upon, right? So it's important to make sure that any tool that you use, it tells you the kind of compliance that you probably have, and it gives you recommendations also, that if you are at a certain level, there are things that you can do to accomplish and go to the next level, right? So taking recommendations in, maybe leverage any tool that gives you that sort of recommendations,
Right.
and also making sure that there are a lot of best practices that all cloud providers have in place currently, right? So make sure you leverage all of these best practices that are given by cloud providers, because that really works for the products that are being built on that particular cloud itself, right? In Google Cloud specifically, I can talk about, there is something called as a recommender, right? A security recommendation that we give it. So when you're building out applications, we tell you if there are certain things that should have been secure, but unknowingly for whatever reason you've not been able to secure it. So there'll be recommendations in place that Google Cloud gives you proactively, in case you forget to probably turn off a security rule or anything else. Otherwise, Google Cloud tells you to turn that security rule off, so that you make sure that there are no implications that can happen if it is running for quite some time. So having said that, I think starting off at the very foundations level, and then building on top of it with a bunch of things that I explained in the presentation, as well as a few things that I mentioned as well.
And Aseem, what are the key lookouts which you will recommend for 2023?
Well, there are a lot to talk about on in security for that, but from DevSecOps point of view, the maturity level has to increase, right? Wherever any company, I mean, from any company's perspective, wherever they are in the journey, whether they are at a very advanced stage or at a nascent stage, I would say let's start the journey, right? And as Akshay also mentioned earlier, right? It's not a destination. In security, there's no destination. It's always a journey, and the fun is about being on that journey. So that's what it's all about. So my recommendation would be to start that journey and have a maturity roadmap. Uh, 1 year out at least, or maybe 6 months out, right? So that brings clarity to the rest of the organization, because DevSecOps is a collaborative effort, is a cultural thing, as Akshay earlier mentioned, right? So I'm echoing your thoughts again and again, because those are really kind of fitting in. So it's a cultural change. So that requires a lot of communication in terms of say leadership's point of view. Everybody should be aligned that yes, this is the right thing to do, and with that kind of alignment, the roadmap has to be published, and then maybe it can be started with say a couple of smaller teams, build a success story, and then build on top of it, right? In my experience, I have not seen a big bang effort in DevSecOps, because that will take too much bandwidth, and it will create too much issues too many places. So it's good to start a small and then go scale up from there. So that brings a lot of success stories, and uh, people really want to help security. So that gets implemented on its own rather than push. It becomes a pull project.
Right. In a very nutshell, you have explained the entire thing and the key takeaways from this discussion today. Akshay, I will request you for your reaction also to the same question.
Absolutely. I think when I look at 2023, what is becoming more and more prominent is security is becoming real, right? Because of the number of threats that we see on an ongoing basis. And there are newer variants of threats that we probably haven't even seen before. Like I
Right.
mentioned in my presentation earlier, right? At every stage of the development, there is an entry door, right? So how do you make sure that your applications are secure at from all of these entry points? Now what I see happening in 2023 and beyond is really that security will become more and more transparent and fine grained into either your application and your development process, right? And you will keep hearing this term, called software supply chain, because that is what it really entails. It really talks about how can you make sure that your entire development life cycle, right from developing to pushing it to production, how do you make sure that everything is secure? So securing the software supply chain is going to be more and more prominent as we progress. As applications are being written in 2022 and 2023 and beyond, you will see the way of implementing security will also keep on changing, right? And I think that comes from the fact that we are becoming applications are becoming more and more serverless. How do you run these applications will be a little different, and how do you monitor and track these applications will also require thinking in a very different way. As you build more and more distributed applications, the complexity keeps on increasing, right? So it's very important that you have sort of a secure software supply chain, and that is where all the things that I mentioned during the presentation really fits into either each of these stages or multiple different stages during the entire software development lifecycle. But I also have to admit that to probably achieve all of this, whatever Aseem mentioned about cultural change and the organization's buy-in, it is actually a prerequisite to doing anything that I'm just talking about, right? Because that is really core and important. If you really have the buy-in and the vision from everybody to do that, achieving that is going to be an organizational goal rather than just a sidekick project of implementing DevSecOps on a very small team. So
Well, that was indeed a very insightful workshop with a lot of major key takeaways from this discussion. And with that, we have come to the end of the session on Reimagining Tech in 2022, presented by Google Cloud and ETCIO. Thank you once again to the speakers, Aseem Rastogi and Akshay Kapoor, for your valuable time and the knowledge you shared here. Thank you to our audience for being so patient and interactive at the same time. Take care and stay safe.
thank you so much, guys.
Thank you.
Take care.